Now, we touched in on timbre in a prior presentation, but want to continue on with it here because the concept of timbre has very practical, applicable implications to the actual playing of our instrument. It being tone color and all, tone color sounds important, and it is. It's the thing that allows us to distinguish one instrument from another instrument, even if they're playing the same note, the same pitch, at the same volume. Even if we're playing the same instrument, we can have variations in timbre, even if they're playing the same note, once again, at the same volume. And the instrument of the guitar, our primary instrument of focus, although the same concept applies to other instruments as well, the guitar has a wide range of different kind of variations because of the way the instrument is designed, because we're actually grabbing the strings with our finger, because we're actually plucking the guitar in some way, either with a pick or our fingernails or part of the flesh of our finger, all of which changes not necessarily the volume, not necessarily the note, but the color of it. So that's the thing we want to kind of dive into here. So definition first. Timbre is the quality or color of sound that makes it distinct from other sounds of the same pitch and volume. Now, as we get into the concept of timbre, it's going to sound a little like kind of ethereal. It's like you're getting a little wonky here in your definitions, in your terminology. Why does it sound like you're describing wine tasting or something like that? And obviously the reason is because we're trying to describe something that has a quality that you can't actually see, and the things that we usually define are with our visual capacities. We as human beings normally have vision as our primary thing to describe things. So when we're trying to describe sound or taste, you start sounding kind of weird, kind of wonky, and sometimes you get these weird terms and you can go off in random directions. However, we have to define it somehow, because definitions are important, because you have to kind of basically be able to communicate what you're getting across. So to somehow come up with some kind of vocabulary for things that aren't concrete, solid, visible becomes difficult but necessary. So it is what allows us to distinguish a violin from a flute or a human voice from the trumpet, even if they are playing the exact same note at the same loudness. So remember, the components that we have that we're typically thinking about is, one, the volume, how loud it is, and two, what's the pitch that we talked about in prior presentation. In our case, what note are we playing? That would be the simplest way to basically say it. What note are they playing? And then what's the volume? Well, you're eliminating this huge range of the color. Now, I want to kind of compare that just to get an idea with our visual components with painting, for example. All the painting, all the colors come from our three primary colors. So from a practical standpoint, you would do the math here and say, well, there can't be that many combinations of colors. There's only three colors. How many other colors can come from that? But obviously the palette of different colors is in essence infinite, right? Similarly with music, you have a similar kind of situation. You have 12 notes. You might say, well, that's more, and the octaves go up infinitely, so there's kind of more combinations, but possibly still manageable to think about all the different combinations of the notes. However, if you take into consideration the timbre, the variations within a particular note, even within the same volume, then you can see the combinations get to be basically infinite that come about. And this is going to be important for a couple different reasons. One is the way we approach the instrument. So notice that when we approach one particular instrument, such as the guitar, we can think about how can we make things a little bit different, even though I'm playing the same note. And obviously we can come up with creative ways to change the timbre, the way we're playing it, which is going to change the resonances around that one wavelength. We're not talking about if we drop our comparison that we saw about in prior presentations, we drop a pebble into the water, we get one big wave, and that's what we define the effect as. But we also get the other littler waves that happen. Those things will change depending on how we approach the playing of the guitar. So that's going to have very practical implications for the playing of one instrument. Obviously, how did we deal with this in the past? We made cool things by putting multiple instruments together that sound differently in, say, an orchestra or something like that, so that you can have all these different effects that have different colors that are now coming together. Now, obviously, in today's age, it's kind of hard not to think about like AI and whatnot when you're considering these concepts as well. Meaning, if they're going to replicate something like a guitar, then how would they do that? Well, if you have a solo guitar, they're going to have to layer different waves on each other as they would naturally be done if you were to drop a pebble into the water, right? It's going to have multiple waves. You can create just one instrument, one note with the distinct sound of a guitar by layering, instead of multiple different instruments, just the different wavelengths that would happen from that one string. But you can see that still gets quite complicated, right? Because what if you're trying to simulate the bending of a string, or attacking the string with a pick versus your finger versus your fingernail, right? All of those things are going to have a tremendous amount of variations, where you can imagine layering it on say music. You can layer your guitar on top of yourself to play with yourself, right? And you can also try to think about layering actual just tones to create one instrument, and then one instrument versus another instrument, which you would imagine is kind of the thing that's happening with the AI. But just realize the complexity of that is amazing that it's doing that, because it's very complex. It's amazing also, just like when they're making the pictures, it's like, that's amazing the amount of complexity that it's putting together with the different colors and shapes and whatnot. It's like an infinite amount of complexity that's coming out somehow. So anyways, timbre equals how a note sounds, not what note it is or how loud it is.